The Strange Attraction of Gale Crater, presented by Science at NASA. Curiosity is about to go to Mars. The car-sized rover, also known as the Mars Science Lab, is scheduled for launch in late November or early December 2011 from the Kennedy Space Center. After an 8-month voyage to Mars, Curiosity will land at the foot of a 3-mile-high mountain in a crater named Gale. It sounds a little odd, a mountain in the middle of an impact crater. Wouldn't the impact have smashed it flat? Some scientists believe the 96-mile-wide crater filled in with sediments over time, and relentless Martian winds carved a mountain in the center, where it now stands nearly 3 times higher than the Grand Canyon is deep. Because of its history, this strangely sculpted mountain is the ideal place for Curiosity to conduct its mission of exploration into the red planet's past. Joy Crisp, MSL Deputy Project Scientist from NASA's Jet Propulsion Lab, explains, "This may be one of the thickest exposed sections of layered sedimentary rocks in the solar system. The rock record preserved in those layers holds stories that are billions of years old, stories about whether, when, and for how long Mars might have been habitable. Today, the red planet is a radiation-drenched, bitterly cold, bleak world. Enormous dust storms explode across the barren landscape and darken Martian skies for months at a time. But data from Mars Reconnaissance Orbiter suggest that Mars once hosted vast lakes and flowing rivers. Gale Crater and its mountain will tell this intriguing story, says Matthew Golombek, Mars Exploration Program landing site scientist from JPL. The layers there chronicle Mars' environmental history. In the gentle slopes around the mountain, Curiosity will prospect for organic molecules, the chemical building blocks of life. Mars Reconnaissance Orbiter has found an intriguing signature of clay near the bottom of the mountain and sulfate minerals a little higher up. Both minerals are formed in the presence of water, which increases potential for life-friendly environments. All the types of aqueous minerals we've detected on Mars to date can be found in this one location, explains Golombek. Clay settles slowly in water and forms little platelets that conform around things, hardening over time and encasing them in casts. Clay could seal organics off from the outside environment, much like it preserved dinosaur bones on Earth. If organics ever existed on Mars, they could be preserved in the clay. Even on planet Earth, teeming with life, finding billion-year-old, well-preserved organics is difficult. But Curiosity will find them if they're present in the samples it takes. The rover is equipped with the most advanced suite of instruments for scientific studies ever sent to the Mars surface. When these are brought to bear on Gale Crater and its mysteriously layered mountain, who knows what discoveries will follow? For updates from the Red Planet, follow your own curiosity to science.nasa.gov.